Action-reaction forces. Many forces are easy to observe. You exert a force every time you exert a ball, pull open a door, or turn the page of your book. Some forces, however, are not so easy to see. For example, you think about the force you feel when you push against a wall. When you push against a solid wall, why doesn't your hand go right through? Did you know that that wall is pushing back? The wall resists your pushing force, preventing you from pushing right through the wall. Newton's third law of motion explains this by stating, for every action, there is an equal and opposite reaction. Another way of saying this is forces always occur in pairs. The photos below show examples of action and reaction force pairs. So looking at this photo, as they kick the ball, there's another force coming from the ball and your foot. And the wall example, there's a force coming from the wall and your hand. Okay. Reaction forces are sometimes hard to spot, but they are always there. If you drop a ball, gravity pulls the ball towards the ground. Gravity is the attractive force between any two objects, in this case, the ball and the earth. What is the reaction force? Believe it or not, the ball also pulls up on Earth with the exact same force. According to Newton's second law of motion, however, Earth's mass is so great that the force of the ball has only a tiny effect on accelerating Earth. However, reaction forces are not the same as balance forces that you learned about in Lesson 4. Action and reaction forces are always the same strength but operate in opposite directions. If you kick a soccer ball softly, its reaction force on you will be soft. If you kick it hard, the reaction force it exerts on you will be hard. The force of your kick is directed towards the ball, and the ball's force is directed towards you. Newton's second law of motion explains why the ball moves away, but you do not. Recall that the change in an object's speed, or its acceleration, depends on its mass. Force pairs also help explain the behavior of objects during collisions. What would happen if you and a classmate both rolled tennis balls that collided? The tennis balls exert forces on each other, causing them to accelerate in opposite directions and bounce back. As you go through your day, think about the forces around you. Perhaps you will see a friend picking up a backpack or see a worker hitting a nail with a hammer. Try to identify the actions and reaction forces that you can observe around you.